Assalamualaikum warahmatullahi wabarakatuh. In this video, we will present to you about queuing theory project. Our group members consist of 5 members. First is Siti Fatimah Aminah Azhar with matrix number 2021602566. Next is me, Dauman Huda Hazim, with matrix number 2021863838. Third is Mimina Jahamidi Koma with matrix number 2021861496. Next is Nur Khairunisa Zahari 2021207348, and lastly Khairatun Najwa Matroni 2021833302. First is introduction. The location for our queuing theory project is at Econjaya Supermarket, Machang, Kelantan. The operating time of Econjaya Machang is from 10 a.m. in the morning to 10 p.m. The time we observed was at 11 a.m. to 12 p.m., which is almost at peak hour. The number of servers are 5, which are the counters for the customer to pay for the goods they buy from Econjaya. The customers of Econjaya mainly come here to buy daily groceries and always need to queue at the counter to pay for their groceries.
Characteristic of queuing system consists of 3 parts, which are arrival, queue discipline, and service facility. First, we start with first characteristic, which is arrival. There are 3 characteristics of arrival. First, population size of arrival is unlimited, which means the number of arrival does not affect the population that arrived. Second, the pattern of arrival is random. Arrivals are said to be random if their occurrence cannot be predicted exactly and they are independent of one another. Since it's a supermarket, so the arrival of customer will be random. The number of arrivals per hour can be estimated by using Poisson distribution, where lambda equal to 18 customers per hour. Last but not least, the behavior of arrivals customer are patient. The arrivals wait in the queue patiently until they are served. There are no bulking and reneging customer because no matter what, they need to complete the transaction to get what they need.
Waiting line characteristic. In this part, we have 2 sections, which is queue line and queue discipline. For queue line, the queuing at the supermarket is unlimited because the length of the queue is unrestricted. For queue discipline, the supermarket uses first come first serve system, where customers are served in the order they arrive at the checkout lanes. So, how does the first come first serve system or discipline work? First, the customer will join the queue. When customer finish shopping, they proceed to the checkout lanes. They join the queue corresponding to the checkout lane they choose. Next, order of service. The cashier at each checkout lane serves customer based on their position in the queue. The customer who arrives first is served first, and the process continues in chronological order. So, first come first serve is a straightforward and fair method, ensuring that customers are served in the order they arrive, without any preferential treatment.
I will explain 2.3 service facility characteristic. The service system is characterized by the number of waiting line, the number of server, the arrangement of the server, and the pattern of service time. For number of channel is multi-channel because Econjaya supermarket consists more than 2 servers. For the number of waiting line, for the Econjaya supermarket is multiple line. Customer can choose which queue to join based on their preference or the perceived wait time in each line. And lastly is number of phases, which is single phase system, where a customer receives service from one station and exit the system. Based on the observation, the pattern of service time at Econjaya supermarket, the mu, which is exponential distribution, is equal to 25 customers per hour. For the basic queuing system configuration for the Econjaya supermarket is multi-server, multi-line, single phase, because there is more than 2 servers and the customer only go through single phase.
Now, we look for the multiple query model calculation for Econjaya. The arrival rate for Econjaya, lambda equal to 18 customer per hour, service rate mu equal to 25 customer per hour, and there are 7 counters but only 5 servers are functioning. To find utilization factor, rho equal to lambda over S multiply mu equal to 18 over 5 multiply 25 equal to 0.14. This represents Econjaya are not extensively occupied, presenting an opportunity to handle a higher customer load without causing congestion. Next, the probability of no customer in the system. The formula was shown in the slide, and after we substitute, we got 0.49. Almost half hour, the system is empty and ready for immediate service. For third calculation, to determine average number of customers in the queue. After we substitute into formula, we got LQ equal to 0. That means there are no customers waiting in line. This outcome underscores the efficiency of our checkout process, translating to a positive customer experience with minimal or no waiting times. Next, average number of customers in the system. L equal to LQ plus lambda over mu equal to 0 plus 18 over 25 equal to 0.72,
approximately to one customer.
The average time a customer must spend in system, W equal to L over lambda equal to 0.72 over 18 equal to 0.04 hours equal to 2.4 minutes. Last, the average time a customer spent in the queue, WQ equal to LQ over lambda equal to 0 over 18 equal to 0 hours, indicate that customers are typically served immediately upon arrival. The assumption of first in, first out is generally satisfied based on the characteristic of the system.
This is our appendix for QM software.
In conclusion, based on calculation, the number of servers provided are adequate and the customers are happy with the waiting time and also happy with Econjaya facilities. The utilization factor indicating that servers are operating at 14% of their capacity on average. The number of servers appear to be adequate based on the low utilization factor, and the customers are likely to be happy with the minimal waiting times both in the queue and in the overall system. From working on a queuing theory project, we have learned that the basic idea of queuing theory, like how many customer comes, how fast service is, how much the system is used, the chance of having customers, how many people are waiting in line, and the average time takes. We have also figured out how to use queuing theory formula to understand and solve problems in real-life situations where there are line and service. Lastly, we have discovered how queuing theory results can help us understand if customers are happy by looking at how long they wait on average and how many are in line.
So that's all from us. Thank you.